So today we will be discussing about the doubt session in your PCB in the 30-day PCB design challenge. So we will come, I will start asking one by one. So if you have any questions, it could be related to the software, or it could be related to the schematic section, or layout design, or else could be routing part. So you can ask your questions right now. And already we have assigned one project to each and every student, and we gave the time frame of 2 weeks, yeah, under which you need to complete starting from schematic section and all the way up to documentation. So everything should be completed within 2 weeks of time frame, and once the submissions we receive, we will go through each and every individual submission, and after scrutinization, so the top two projects will be selected, under which we will be providing assistance for fabrication. So from our Suchna end, we will provide you the financial support for fabrication. So we can start working on it. So among that, we will start one by one. So Teja, Nirud, do you have any questions related to a project? Teja, Nirud, you can unmute yourself. Yeah, Ayub, do you have any questions? Charan, do you have any questions? Varnit, so could be related to EasyEDA or anything else. You have any questions? Yeah. So also we missed discussing about one more concept, like about UL. Okay, so UL, yeah, someone raised your hand. Yes, Charan, what's your question? My voice is not loud. Okay. Yeah, now I think it's fixed, right? Are you able to hear me now? Okay, fine. So yeah, Charan, I think you're having some question, right? So how many of you completed the routing section? It could be top copper layer or bottom copper. So can someone just present your project? Anyone randomly. So it could be Charan or Ibrahim. Anyone, you can just start sharing your screen. I will give you the I mean, I will modify the host controls. Okay, so yeah, already it's enabled. You can start sharing your screen. I will be reviewing your project. So if you have any specific question, you can ask me now. Okay, I will take one more review session as well. Probably within this week only. So around one or two review sessions I will take, so that within these review sessions already we completed all the concepts, right? Starting from copper track width derivation, how to determine the width of the copper traces. Yeah, Ibrahim, no worries. I can take a separate session again. I will notify you. Okay. See, actually, what's one of the disadvantage of EasyEDA is that, so in EasyEDA, it's not very easy to import or to manage. Let's say if you take KiCad or Altium Designer, for each and individual component, you can create a symbol, and for each and every symbol, you can assign a footprint. So, and you can also assign a 3D model for each and every component. If you take Altium Designer or KiCad. But natively in EasyEDA, it doesn't support all those functionalities. That's why it's a very minimal software. See, this EasyEDA doesn't require any installations, right? It can directly run on your in your browser. The reason is that it is very minimalistic version. Unlike KiCad and Altium Designer, they are like highly advanced applications through which we can design what for a different component also we can change the footprints as per your requirement. You can change your footprints as well. And similarly, 3D models can also be applied to any particular component by downloading from online. So there are I will show you one of such website which is called as SnapEDA. So this is one of the famous website which like a repository of all the components. So whatever the components, see already it is showing over here, it's around over 25 million parts are available. Just like LCSC, SnapEDA is like a huge library where they are maintaining over 25 plus million parts. So let's say if you want something like a SGP40, you can search for SGP40. Okay, you will get it. See, this is the sensor on SGP40. Okay, so you need to go, you know, to just navigate to that particular component, and this is the symbol of that component. Okay, this is the symbol. See, while I hope you are able to see my screen, right? Yeah. So while you are working on the schematic section in the PCB designing, the first part is first we need to make the circuit diagram. First we need to make the schematic section. So in the schematic section, we use symbols, right? So we will be going to LCSC library. See, actually what I taught you is like, first we need to go to LCSC library, and from the LCSC library, you can search for whatever the component that you want. Let's say you want something like relay module or whatever, maybe you can search for that particular module and you will get it. Okay, but not all the components are available in LCSC. Okay, since you are in the very beginning as you are very beginners to the PCB designing, I told you that LCSC you can find all the components, but you can find most of the components but not all the components. Few components are also missing in LCSC as well. Okay, so in such a case what you need to do if it is missing, so there are two main alternatives available. The first thing is like exporting an external project. So you need to import an external project. The second thing is like you need to create the symbols on yourself. See, if no symbol is there, you need to create this particular symbol on yourself. By default, whenever you are just trying to import, let's say if you want this particular capacitor on the PCB, so you will be navigating to LCSC library, and from here you will be copying the manufacturer part number, MPN, manufacturer part number, or else LCSC part number. You can copy either of these, or with either MPN or LCSC part number. With the help of any one of these, you can directly place this particular component in schematic section or whatever maybe. And one of the important thing that you need to understand is like whenever you are using LCSC library, you are not importing symbol separately, and you are not importing the 3D model separately, nor the footprint. Okay, when you just directly copy this part number and you paste it in the LCSC library manager section and you click on place option, automatically all these footprints, whatever the library, I mean files which are related to component are automatically getting they're already pre linked with it, because LCS is already partnered with the EasyEDA. So it can automatically fetch the symbol and all the stuff from the database, and it can directly show you in the schematic section. But do remember, this is not always possible. Okay, let's say you are looking for some component which may be missing in LCSC library, then how will you be able to place it in the EasyEDA? Okay, that's very important. So that's why most of the people, see, when you are working on simpler projects like casual projects, you can use EasyEDA, but it is not preferred for higher applications in PCB. That's why these are the drawbacks of EasyEDA. to be more specific. That's why people choose EC, KiCad or some other thing like Eagle, OrCAD, or maybe Altium Designer. So Altium Designer is regarded as one of the best PCB designing software. So already you might be aware of it. If you check the rankings of the various PCB designing softwares, Altium Designer is ranked among the top. So already Altium Designer company is also running so many online campaigns and so many outreach activities through which you can get involved and get to know how to use Altium Designer. So they will be giving an intro, and if you are those who are interested in learning more about Altium, so they can go with either Suchna, or there may be online courses available as well. So you can also opt in for Suchna, where we will be collaborating with Groyota LLP Chennai, and we'll be offering you courses from expert mentors from Victor Vellur and Amrita Viswavidyapeetham. Yeah, and we have one or two professors from IITM. So yeah, here the thing is like I will show you how to create a symbol on yourself. Okay, so I will be taking two or three review sessions within this week only, because this thing is actually should not be taught in the beginner course. So the reason why we give the projects to you is that so few people have been uh, worrying that whether we are unable to place few components. Okay, so the thing is like all components are not available in LCSC, but though it is not available in LCSC, there is a high probability that it is available in SnapEDA. Okay, because it is over 25 plus million components. But what if it is not also available in SnapEDA? Okay, so that's why SnapEDA gave you one more option where you need to specify the requirements of the component. Okay, let's say you want to place SGP40. Okay, sensor on SGP40, one kind of sensor. So it is now missing in SnapEDA. Okay, just assume it is there in SnapEDA. Let just assume that if it is missing in SnapEDA, so then they will be providing you a form in which you need to fill out the details and specific requirements of the component. Okay, then automatically SnapEDA engineers will be designing that symbol, footprint, 3D model, everything for you. Okay, there would be something like a processing fee, but I don't know exactly, depending upon the application, depending upon the complexity. But still, see, here you can, if any particular component is missing in SnapEDA, you can directly you can submit a message or a notification to SnapEDA. The engineers at SnapEDA will receive your component specifications. Okay, they will start initiating work on it. Okay, so that is possible. So that's why SnapEDA, see, if you want to place this particular component, like, see here, given different formats. Okay, the first one is Altium Circuit Studio, CR8000 or 5000, Design Spark PCB, DipTrace, Eagle, and there are many PCB designing applications including KiCad and PCAD, PCB123. All these are different kinds of tools. So, but here if you just observe this particular list in the download, where in the drop down option, EasyEDA format is missing. See, even in SnapEDA, which is widely used famous tool, EasyEDA is missing. Okay. See, this is so Simon's Expedition. This is highly enterprise related tool. So generally, hobbyists usually go with professional and mid market tier, like something like a Altium Designer, Cadence OrCAD. Already we discussed about OrCAD. So this specific theme is also available in ECEDA. In the primitive styling, you can change bit, we can switch between multiple styles, right? In primitive styling, where we have already discussed about primitive style. So hope you remember, like how the circuit, how the schematics and all the symbols get rendered. And see, and next one is Simon's Patch Professional.
So if you just take a look, if you just observe this particular thing, you can understand that EasyEDA is at just entry level. Okay, it's just at entry level. So it is containing some browser-based tools that you can integrate in order to do the fabrication. But higher up, much more functionalities are not available in EasyEDA. For them, you need to refer to Altium Designer. So Altium Designer is regarded as the most popular environment for professional engineering teams. And then of course, Cadence, Orcad, and Siemens Patch Professional are also giving good competition with Altium Designer. But still, Altium, many people prefer Altium over other things. But there are still followers who usually go with Orcad or some other thing. Okay. So from this, you can understand ECEDA is at no, given the least priority in the positioning. It is given as at the least positioning. The reason is that it is having so many drawbacks. Okay, so it is not, it is not having that much of huge libraries which can you can readily download and import symbols and footprints externally. So if you want to import any kind of symbol, so first you need to download into any one of the format, like let's say something like eagle, okay, or else you can go with KiCad, or else some other component like OrCAD, some other PCB application tool like OrCAD. First you need to export it into a different format among these particular available formats. See, if you just take a look in the ECEDA user interface, there would be an import option. Okay, there will be an import option. So I'm going to the home screen. Okay. So if you just navigate in the top navigation bar, first go to file and then click on import option. So here you can find a few options, right? Like ECEDA Professional, ECEDA Standard, and then Altium Designer, OrCAD, Eagle, KiCad, PATS or PATS Pro, and then see PATS or PATS Pro. This is also a very powerful tool equivalent to Altium Designer. So already we discussed. So both are professional standard, okay, highly professional standard. And what we are discussing right now in the beginner session, what we discussed in the last 30 days about ECEDA is just like to introduce you about how PCB designing, what's the workflow, what are the different steps involved in making a PCB. So we gave you a lot of theoretical knowledge starting from manufacturing process inside a factory, and chemistry behind etching process, copper traces, how to determine the width of the copper traces, silk screen lab, and uh, we discussed about gold fingers, and along with these we discussed about few DRCs, design rule verification, design rule checks. So what DRCs that we should follow if we are using a gold finger, and then we discussed about characteristic impedance formula, where we revealed that not only the width is playing an important role in the efficiency and the signal transmission of in the PCB, but also the height of the laminate material which we are using FR4. The height of the laminate material also plays an important role because it affects the overall characteristic impedance, which decides the speed of the transmission of data in PCB. So similarly, we discussed many things, like we discussed about environmental safety, consumer safety, polybrominated biphenyls, polybrominated diphenyl ethers, and uh, endocrine disrupting chemicals. So chemistry behind that, ROHS, restriction of hazardous substances, 10 different chemicals which are banned in European Union uh, in the manufacturing of PCBs. So all these we discussed is around 50% theoretical and 50% application. So those who want to explore in detail, so they can either go with, I suggest you to go with either Altium Designer or KiCad. So I prefer you to go with the Altium Designer, which is the professional standard PCB designing. And the next batch starts on within 2 or 3 days. Exact date will be announced in the official community, Meta Verified community, Suchna community group. That will be shared by the administration team in the WhatsApp. You can refer to that. So here, if you want to see, here there are multiple import options, right? Eagle, KiCad. So many. First, let's say if you want to import some Eagle project into EasyEDA or else KiCad project. So let's say I'm clicking on Eagle. Okay, click on confirm. So these are, I have already downloaded these particular files from I mean SnapEDA. Okay, but if you want to use SnapEDA, first you need to have an account in SnapEDA. Okay, first you need to have a login credentials. Unless you log in, you cannot directly download any kind of file format. First, you need to create an account, and also make sure that when you create a SnapEDA account, make sure that your mobile number is verified. Okay, so not just directly. Sometimes, if you repeatedly downloading many kinds of file formats, or if any unusual activity is detected by SnapEDA automated system, there is a high probability that your account is blocked temporarily. So then you will be asked, a pop-up menu would appear in SnapEDA asking you for complete the mobile verification, where you can enter your mobile number and the OTP which is received on your mobile number, and then you can authenticate yourself, and then you can start using the SnapEDA tool. So usually it won't happen, but I'm just letting you know. But if in case if it asks you for authenticate yourself, or if it is showing that your account is banned temporarily due to violating their terms and conditions of use, then you are supposed to do the mobile verification. But even after the verification, uh, so if it doesn't resolve, you need to send a mail to the support team. Okay. Yeah, just give me a second. I'm getting one more call. Lohit. Lohit. తీసుకుంటా లోహిత్ ఇప్పుడు ఒక 20 minutes వేరే క్లాస్లో ఉంది అది అయిపోయినామంటే తీసుకుంటా ఆ, నీకు కాల్ చేస్తాను నేను. Yeah. So after authenticating, you can start using SnapEDA tool. Okay. So in SnapEDA, you can find all the components. So the best part about the Altium design is like there are so many useful features. So not only see at each and every section, at each and every step of PCB designing, starting from schematic, creating project, everything. So there are many advanced features. When we compare to ECEDA, so many advanced features are there. Okay, I'll show you. Yeah. So this is what I got. Okay, importing external components in ECEDA can be frustrating due to its ecosystem constraint. So the ecosystem is not that much flexible for you to import the external component. It is not flexible. So the primary drawback of importing components from KiCad or Altium or any other generic vendors. So manual footprint mapping. When you importing external schematics, symbols and footprints rarely link automatically. You must manually align. So usually it is not a very easy to import the external components in ECEDA, because even if you check the SnapEDA, which is widely used for importing library, importing the components externally into your vendor, okay, your PCB designing application. So all kinds of file formats or PCB file for design formats are available except ECEDA. So ECEDA is missing here. So from this you can understand. So that's why people are using, because if you are using KiCad or something like Altium Designer, if the component is missing in your library, system library or else Altium internal libraries, then you can directly go to SnapEDA, search for, just like as we are using LCSC for ECEDA, similarly SnapEDA is having even more components, over 25 plus million components are available. So even though if there's any possibility that if the component is missing in SnapEDA, you can send a request to SnapEDA or SnapMagic team asking for to make the component available in your repository. So they will ask you for the specifications, what kind of component and its a dimension, or it's a related technical parameters. Or if you are having a datasheet URL, you can share a datasheet URL with them. They will make, the designers and engineers at SnapEDA will be starting working on your component. They will review your uh, your specific requirements, and they will make the symbol available publicly. Okay. So that is the main advantage that we are having with other vendors except EasyEDA. So in EasyEDA still you have an option where you can create your own symbol. Okay. So I'll show you how to create a symbol. So first I'm clicking on file and then click on new option. Okay. First navigate to file, click on new, and then here you will be having option called symbol. Okay. Here you will be having symbol option. So click on symbol and you need to give the symbol name. And here you need to select the symbol category. So there are different categories available like a component symbol, net flag symbol, net port, and off page connector, drawing symbol, and non-electronic symbol. So here around six types, six categories have been provided: component, net flag, net port, off page connector, drawing symbol, and non-electronic symbol. So among these six, you need to check whatever the component that you are trying to create falls under which category. So let's say if you are trying to, let's take the example of SGP40. So I'm sure that you know about SGP40, right? Which is actually designed by Senseron company. SGP40. There are other variants available like SGP30, which is the predecessor sublet. It's like a predecessor of SGP40. Okay, SGP30. Yeah, this Senseron SGP40 is like a volatile organic compound, VOC, volatile organic compound sensor. So basically it is used for AQI, air quality indexing. So with the help of SGP sensor, you can determine how much, what's the quality and of the air. So electronically, so it will be able to generate some analog signal, and you will be having analog to digital converters in your microcontroller that will be converting the analog signal into digital signal. And finally, you can get that output, the quality of the air in terms of a numerical value. So SGP40, this is the SGP40. It works under I square C principle. So if you just magnify this image, you can see a particular IC integrated circuit over here. So this particular IC is the SGP40 IC, which is manufactured by Senseron company. Okay. So for those who have given SGP40, so if SGP40 is not available in LCSC, you can type for SGP30. Okay, you can take another version which is available. Just look for SGP which it could be different version also, no problem. So you can work on that as well. Okay, but if in case it's not available, the two alternatives available is like first you need to export into either any one of the uh, so you can click on file option and click on import. So few options would be displaying, right? If you when you click on import option, so make sure that you are importing. Yeah, if you are exporting from the, I mean, if you are downloading from Snap EDA, make sure that the file form download file format is among these supported file formats. It could be any one of these things. Okay, it could be any one of these things. So once you are done with the importing, then you can start using that. Okay, but there are so many drawbacks that few components which are imported, from the other vendors, PCB vendors, like usually there's a probability that it will undergo mutation. Okay, there's a high probability that it will undergo mutation. Not always it is rendered the same as it is, just like as it is exported from the original vendor. So there would be a little bit mutation. So that's why I suggest you kindly please go with either Altium Designer course or else a KiCad. Anything you can prefer. So both are highly professional standard. So yeah, here first time, yeah, first let me go to something like
Yeah, so I just created a new project, and so here, so every IC will be having something like a footprint. Okay, so every IC will be having something like a footprint. So there are so many, we usually call, technically we call it as the package. Okay, there are so many packages available. I will show you. So if a specific IC is not available, then what should you need to do? In EasyEDA, if let's assume that SGP40 is not available. Okay, then what? So you need to look for any other package. Okay, any other thing which is having the same package. Okay, anything which is having the same package. So I will show you what is the IC package mean. There are so many types in IC package as well. See, all these are different kinds of packages. So package means basically here you can see different IC appears to be in a different style, right? So this is QFN, QFP, DIP, BGA, SOP, SOT23, and SOT223. So all these are different kinds of packagings. Okay. So you need to choose any other component which is having the same kind of uh, packaging. Okay. So DIP means dual inline package. Okay, DIP means dual inline package, and SOP means small outline package, and TSOP means thin small outline package, and QFP means quad flat package. QFPE, quad flat package extended. It is an extended version of QFP. Okay, this is the thin small outline package, and this is small outline package. So we have one SOP and TSOP. Okay, thin small outline package. This is small outline package, and this is QFP, quad flat package, and quad flat package extended version. So this is QFN, where N means no leads, no leads. Okay, so we will see what is QFN, where what does this no leads mean. We will see that. And coming to BGA, which is also widely used, called as ball grid array. Okay, BGA refers to ball grid array. And then we have, similarly we have so many types. See, all these are different kinds of packagings in IC manufacturing. So this is the ball grid array. If you just check this particular thing over here, so it's like dotted things, right? So that's why it is called as ball grid array. Okay, so this is dual inline package. Yeah. So like this we are having so many different kinds of packages. Yeah, so if you just observe this particular component QFN and QFP, this is quad flat package, right? QFP means quad flat package, whereas QFN means quad flat package, but it is not having leads. So what does this leads mean? See, if you just check this particular QFP, so it is having some outer leads, right? Which we can use for the connection. Okay, so we are having so many leads over here. But if you check this particular QFN package, there are no leads. Okay, basically QFN and QFP packages are same, except this particular absence of leads. So QFN is having a vacancy, I mean, it is not having the leads. Okay, whereas QFP package is having quad flat package. By default, it will have some leads. So these particular outer pins that you can see, right, these are actually called as leads. But if you take QFN, there is no such kind of leads. Okay, so this is SOT23 and this is SOT223. Okay, so there would be even change in the dimensions. Okay, once you if you just move, change between different kinds of packages, the dimension of the ICs uh, and their properties would vary a lot. So dimensions would vary a lot. It could be size of SOT23 and SOT223 are different. So one kind of package may be appearing little bit larger, while other no, kind of package is appearing a little bit smaller. So, and this is SOP, and this is also another kind of thing. So like this we are having so many kinds of packages. So now Now what we need to understand is that SGP40 is having what kind of package. Once if you are able to determine what is the package, what kind of package does SGP40 is using, then you will be able to place an alternative component which is having same kind of manufacture package. Okay, SGP40. So this thing you can find in the data sheet. You can just simply go to the manufacturer sheet. There you can find the entire technical information. What kind of packages are available? All the information is already made publicly accessible and available by Sensiron company for their products at least. Okay, SGP40 package, or you can search SGP40 sensor IC package. So this is the official Sensiron website, official website of Sensiron, where you can find this particular PDF. It contains complete documentation about Sensiron products SGP40. So here it is mentioned that this particular component is, see, if you just observe this, you are able to easily understand that it is something like something, it is in square shape. Okay, and now you need to determine whether this is having leads or no leads. So if you just observe this particular region, you cannot find any outer prolonged version, right? No outer prolongations, just simply a conductive path over here. Okay, so that means it is not having any kind of leads, so it is leads are absent in SGP40. Okay, so that's what mentioned over here. Okay, DFN is also one kind of package. I'll show you. All these are properties of DFN packages. Dual flat, no lead. Okay, dual flat, no lead. So these are like different packagings. Okay, IC can be fabricated in any kind of format. It could be DFN or QFN. So those who are interested to know more about these particular information about different packages, how to create our own symbol, and how to create our own footprints, so this can be taught in the, in the upcoming course. So in DFN package versus QFN, you can find the comparison between them. So in DFN package there are no external leads. Similarly in QFN package also there are no external leads. But do remember in QFP, okay, if you take the difference between QFN and QFP is that in QFP you can find leads. Okay, but in QFN you cannot, quad flat no lead. Okay, quad flat no lead, there you cannot find any kind of leads. But in QFP quad flat package, there you can find leads as well. So in DFN dual flat no lead, as the name suggests, whenever if there's in present in the package name, so usually it is used to indicate that there are no leads. So in both the modules there are no leads. But why it is called as DFN? Why it is called as dual flat? Not, what is the difference between them? So both are not having the leads. So that's why we are the word is ending with N, which means no leads. But why it is dual flat and that is quad flat? The reason is that if you just observe the shape of the QFN and DFN and QFN, in DFN only two sides are flat, whereas in QFN, so as the name suggests quad, that means all four sides. Okay, uh, I'll show you the QFN as well. Okay, see, quad flat no leads features electrical contacts on all four sides of the package, supporting higher pin counts and complex input output. So dual flat, no lead based on flat, right? We need to check based on flat. So this is the primary difference. The primary difference lies in the pin layout. QFN has pads on all four sides, making it ideal for high density, high pin count chips, while DFN has pads only on two sides. See, if you want to able to understand the difference between QFN and DFN, you need to check the back side. Okay, you need to check the back side of the if you let's say if the upper surface you take it as the anterior and the lower surface if you take it as the posterior, so you need to check the posterior surface, that means the back side. Okay, not the anterior, because pads are present in the lower surface, right? So just check the lower surface of QFN and DFN, then you can easily understand what's the difference between QFN and DFN. So now I'm just showing you the back side of the QFN. See, this is the back side of the QFN package. Quad flat, no leads. Okay, see, these are the pads. Okay, so pads are like they are having the electrical conductivity. Pads have electrical conductivity. See, if you want to connect this particular IC, in schematic section to any other component, usually in schematic section there will be a symbol, right? So the each and every symbol will have some pinouts. They are labeled with either V input or VCC or ground or serial clock, serial data, and you will be doing the connections and wiring all the thing. But that's not the only thing that you need to understand. You also need to know what kind of package does the IC is using. So ICs are fabricated in many kinds of packages, DFN, QFN, DFP, dual line. So like that, there are so many kinds of packages. So you need to determine what kind of package are you using. Okay, so if you check the backside of this QFN package, so these pads are, so these are the main. See, here we are having so many kinds of pads, right? So basically in the schematic section, if you are trying to place this particular symbol in the schematic window, so there you will be placing the symbol, right? So those symbols like what are labeled with VCC, ground, all these are originating from these pads only. Okay, so basically these pads for which a label, a reference name like VCC, ground, serial clock, serial data, SD0, all these are labeled, and those and these things you are connecting with the help of wire tool to, let's say, if you want to ground the SD0 pin. We already discussed about I2C address, isn't it? Integrated uh, communication protocol, I2C protocol. So in I2C protocol, we discussed how the data is transmitted between the master and the slave. If it in the master slave relationship, how the data is being exchanged, transmitted between a master and the slave. So there we discussed how to connect these uh, different kinds of pins to different components. Okay, from the symbol. But actually, whatever that VCC, ground, serial clock, serial data, those are actually originating from these pads only. Okay, so here these pads, these are like SMD, surface mount. You can directly mount these on the surface. Okay, so but if you take a in QFP also surface mountable mounted components are there. Okay, so this is the QFN. It is not having any leads, but if you take QFP, it will have leads. Outer prolongation. See, this is QFP. See, this is QFP. It is having leads. Okay, but the one thing that you need to observe is that these leads are present on four directions, on all four sides. Okay, so that's why it is called as quad means four. So leads are symmetrically arranged in all the four dimensions, all the four directions of a IC. So this is the QFP package. But if you take a DFN or DFP package, I'll show you the DFN package as well. So right now what I'm showing is the DFN package. See, this is the DFN package. See, in DFN package, only these pads are available on the right side and the left side. Okay, on the right side and the left side, but not present on the uh, you know this particular direction and this particular direction. Only it is there on the two sides. Only on two sides. It is not there on, it is, pads are not present on all four directions or on all four sides. So since it is there, pads are present only on two sides of a package, it is called as dual flat package. That means pads are there in only two sides. But in QFN and QFP package, these pads are there on all four sides. So completely the entire all four directions. There is something called DFP package as well. DFP package. So this DFP is also called as DIP, dual inline package. DFP, dual flat package or dual inline package. So in this dual inline package, again these leads are present on two directions. Okay. So in QFP we are having leads on all the four directions. Similarly in DIP, dual inline package, we are having leads on both on the two sides. But in QFN if you take, pads are there on all four sides, but leads are absent. Similarly in QFP also, pads are there on all the four directions, but leads are present. Okay, so this is the major difference between different kinds of packages. So now if you just go back to the previous thing where what we discussed about SGP40. So this SGP40 is having 6-pin DFN package. Okay, this is 6-pin DFN package. So what does this 6-pin DFN package mean? So I'll show you. See, if you just count the number of pins on either sides, okay. So 1, 2, 3, 4, 5, 6. Total 6 pins are there. Okay, that means 3 pins on one side and another 3 pins on another side. This is dual inline package, but not actually dual inline package because pads are not there. So if pads are not there, then you need to call it as DFP, dual flat package, where the leads are absent. So but in total it is having 6 pads. This is pad 1, pad 2, pad 3, pad 4, pad 5, pad 6. So that's why it comes under the 6 pin DFN package. So total it is having 6 pins. And these are the dimensions. Okay, 2.44 into 2.44 into 0.85 cube. These are the dimensions of the 6 pin DFN package. These dimensions are not just the dimensions of SGP40. Okay, these dimensions are chosen because these dimensions belongs to the particular package which is used by the Sensiron company in fabrication of a SGP40 IC, that is 6 pin DFN package. Okay, these particular dimensions are actually belonging to 6 pin DFN package. Since SGP40 is using the DFN package, so the properties of all the properties of DFN package are inherited directly to the SGP. Okay, SGP40 IC. It could be dimensions or pads arrangement, the symmetricality present on two sides, isn't it? So all these are directly inherited from the actual DFN package. So also this SGP40 is having lower power consumption, around 2.6 milliamps. It just consumes 2.6 milliamps at 3.3 voltage. So if you want to know more information about uh, different kinds of packages, so information is available. You can make a research on it about different kinds of packages which are widely used in the fabrication of ICs. So coming back to 6-pin DFN, now what we need to understand is like how to place 6-pin DFN package in EasyEDA. See, Altium designer KaiCAD is having a huge community. So there are so many WhatsApp groups over thousands, millions of PCB engineers across the globe connected together. There are so many communities for PCB design. So there you can exchange you can post your questions. And recently Stack Overflow, which is widely used for posting programming or other related questions, so already they created a separate stack platforms where you can, for electronics, where you can post questions in electronics. So there also you can post your questions related to the PCB design. So people from different companies would be answering them. So you can take help of that Stack Overflow platform where you can post your questions and get solution. But nowadays, if you post a question, it is taking months or even years for getting answered, because people are not actually participating in those, because all these platforms are newly came, right? They are not as much as old as we are having the Stack Overflow, the main Stack Overflow, which is actually used for posting the programming related questions if you are having any such kind of thing. Yeah. So if you want to place something like a DFN, you need to search for the specific package name like DFN6. So or else the exact part number also you can search. So from this you will be able to place a component. Okay, I will show you. DFN6 package LCSC. Yeah. So first I will show you how to create a new symbol on yourself. Click on file option and then go to new and click on symbol. Okay, file new and then symbol, and then here you need to give the name of the symbol. Let's say I'm giving SGP or else Sensiron 40, Sensiron underscore SGP 40. So once if you click on the save option, automatically a new window would appear where you need to draft, design and draft the entire symbol. Yeah, first I'm clicking on, see, this is the empty space where you need to actually design what should be the symbol of the component. Okay, see already here I'm having these particular footprints already there in my system. Okay, related to SGP30. So already have SGP30 on my system. So Ibrahim, did I give you the project SGP30 or SGP40? So in the last session where I assigned you the project, so what's the thing that which I allocated to you? SGP30. Okay, so you are unable to find the SGP30 component, right, in LCSC library, because I already told you in LCSC all the components may not be available. So if you type SGP30, so you got only one search result. Okay, you got something SG, but this is not actually what the IC that we are looking for. It is some other component. We got something, but this is not the actual IC that we are looking for. See, if you just take the company name, it should be Sensiron, but here it is Infineon. Both are different. See, the entire packaging is also different. This is TO220 package. This is how it. See, I'll show you TO220 package. So this is how TO. You might have seen this kind of structure in transistors, MOSFETs, N channel MOSFET and P channel MOSFET. You might have seen this structure, right? So here we are having one hole, right, where this is used for connecting this particular package with the heat sink. So you can connect these TO220 packages with heat sink as well. So now from the discussion, what is clear, Ibrahim? What is clear for you? So if the actual component is not available, so what we need to do? Yeah. So anyone able to summarize what is the thing? Uh, what's your understanding from our discussion? So what is clear? What do you understand from the discussion? If the component is not available, then what you need to do? Yeah. So the thing is, if the component is not available, then you need to look for any particular IC which is having the same package. Okay. The first thing you need to do is you need to export an external library. I already shown you the SnapEDA. Here you can download either into Altium. See, you can download into Altium, or you can download as Eagle format, or else you can download something like a KiCad. See, if you just click on KiCad, it will ask you for version. So V3 and prior, V4 and later, click on V6 and later. So once you click on V6 and later, it will automatically the zip folder, okay, compressed zip folder, compressed format file will be installed on your device. Now again navigate to EasyEDA, then there will be import option. Okay, so again in EasyEDA will be having an import option. So click on file, click on import option, click on KiCad, if because we have exported the KiCad file format, click on confirm, and then select the zip folder, and then click on import document and extract libraries, and then yeah, you can keep the rest all other configuration as is, and you can click on import option. Okay, so once you click on the import option, it is showing three different things: SGP40, D under. So you said SGP30, right? Is it 30 or 40? Chart is clear. Can just again send post a message in the chat box. Is it SGP30 or 40? SGP30. Okay. So for SGP30, what you need to do? First, you need to go to SnapEDA, snapeda.com. So then here you can search for SGP30, SGP30. See, even if the component is not there in LCSC, it will definitely exist in SnapEDA. Yes, Ibrahim, you have a question. Okay, you can't see my screen, right? I will reshare.